Siddiqui, and I will be your MC for the session. With me is Yasmin Amenajad, Assistant Professor at the Faculty of Science and Technology, and Sapita Goli, who is the Chair of the IEEE Women in Engineering Southern Alberta section. Before we begin, I would just like to mention that we are going to record the workshop session, and we will share the recording in the event webpage if the workshop facilitators approve the distribution for Monday's session as well as today's session. So just change my slide here. So just a few last housekeeping rules for this meeting. During the event, please keep your microphone muted. The chat will be closed during the event, but feel free to type in your questions in the Q&A area to the right of your Google Meet window. To get there, you will want to click on the activities button, the one with all the shapes, and then select Q&A and ask your question there. Please note we do have a designated Q&A session at the end to answer all questions, and they will be reviewed and answered at that time. So the topic of using cloud APIs for AI and machine learning is becoming very popular, and learning from it from experienced people who are part of the great team behind building these technologies is indeed invaluable. In today's workshop, our representatives from Amazon Web Services will be giving you all a look at Amazon SageMaker to use and deploy ML models. For this, when our invited speakers accepted to run this event for the participants of Hack Together, we had also decided to use this opportunity to open the event to a broader audience in Alberta. So with that being said, we are pleased to see so many undergraduate, graduate, and graduate students and faculty and research staff at this event. We welcome you all, and we hope that you are all able to take away something from this experience that will help you with your projects in the future. So we are grateful to have representatives from Amazon Web Services to facilitate this event. We have here with us Tulsi Garg, and joining with him is Hatem Sayala. They also facilitated the event on Monday, wherein they gave us overviews of the APIs for AI and ML that Amazon Web Services has to offer. Tulsi Garg is a senior solutions architect with AWS for the last 3.5 years, and he's been helping public sector customers with their cloud journeys. He has a passion for artificial intelligence and machine learning, and with a particular interest in automating machine learning use cases. He strongly believes in making ML accessible to everyone instead of just a few specialized roles in the enterprise. Hatem Sayala has been a solutions architect with AWS for the last 3 years. He's helped commercial and public sector customers in a variety of roles. His passions include big data and search technologies. I will now hand it off to Tulsi and Hatem to kick off the event. Thank you both.
Thank you, Kurat. Hello, everyone. My name is Tulsi Garg, and I will be taking you through the presentation today. The content today is focused on, so like she mentioned, on Monday we covered the services or the AI part of it. And today we are focused a little bit more on the SageMaker platform. So SageMaker is one of the services in AWS that lets the data scientists and developers create their own models. So as opposed to the session focused on APIs last time, this session will go deeper into, what does it take to create a model? What are some of the typical challenges faced by data scientists or developers when they're going through this journey, and how AWS SageMaker bridges that gap and is able to accelerate that machine learning journey for various stakeholders in the enterprise. So with that said, I'm sharing my screen. Okay. So like I mentioned, we'll go through a few slides in which I'll cover some of the details of the platform, what kind of ML journey is and why it makes sense to use AWS for your needs, and then look at specifically into SageMaker platform. And then towards the end, we'll also have, a quick demonstration, if you will, where I will showcase kind of SageMaker in action, and I'll also point you to a few of the resources that are available openly through GitHub, right, where you have ready-to-go notebooks that you can take and work on, let's say, focus on various aspects of the machine learning problems. So machine learning went from being an aspirational technology to a mainstream extremely fast as we are looking through the journey of various enterprises. For a long time, the technology was limited to a few major tech companies and hardcore academic researchers. But things have begun to change, especially around the cloud computing when it kind of started becoming mainstream. So compute power and data became more and more available, and quite literally, machine learning is now making an impact across every industry, whether that is finance, retail, fashion, real estate, or healthcare. So we have customers that are spread across kind of these industries, and they're able to make machine learning embed them into their core applications. It's moving from a peripheral to now a core part of every business and industry for them. Amazon itself is an example of a company that went through a multi-year machine learning journey in order to be ML-driven company that you see today. So Amazon had been applying machine learning in areas such as personalization and supply chain for more than 20 years. And ML is an integral part of Amazon. We have improved that original personalization model significantly over time and moved it to other products such as Amazon Prime as well. We use ML throughout our fulfillment process, including developing a forecasting system that can predict the appropriate amount of demand for each product we sell. And worldwide, in order to deliver on a customer expectation or convenience at the cost and delivery speeds that we are able to offer. We have developed natural language processing technology to give consumers an entirely new way to interact with technology through Alexa. We have also developed groundbreaking technology with autonomous flight via Prime Air drones and using robotics in our fulfillment centers to get packages to our consumers faster. This was a big culture change for us, but it's something that every organization can do. So the idea behind the AWS services in general, and more specifically around machine learning services, is to bring those same capabilities to our customers in an easier fashion. For all the progress that we have made in machine learning, there are still some common challenges that we have observed that keep most organizations from implementing machine learning. According to a survey by McKinsey in 2019, 65% from the high performers have reported a clear data strategy. So one of the key concepts there is organizations that we see that are becoming more and more successful at utilizing machine learning have a really grounded data strategy and data structuring approach, where they understand what their data assets are and they're able to utilize them to be able to create these predictive outcomes. Also, according to one of the Gartner surveys in 2019, skill of the staff is rated as the #1 blocker in AI adoption. And more than 56% of people cite it as a blocker. So some of the focus in the presentation today and otherwise, as you will see, is to make these services easier, to take away the pain from the usual activities that need to be performed while you're utilizing these things. So in terms of why make use of AWS, so we talked about generally about why ML is important and how businesses are kind of planning to utilize it. AWS more specifically because, first of all, because we provide the broadest and deepest set of machine learning and AI services for your business. And AWS is unmatched in its breadth and depth of capabilities we offer to our customers. We launched more than 250 new features and services in the last year, and no other provider has done more than half as many as we have launched. Our pace is only accelerating. Developers they typically love waking up to new functionality every day at their fingertips because behind the scenes services keep improving every day. Developers with no prior machine learning experience can easily build sophisticated AI-driven applications spanning computer vision, language recommendations, and forecasting, many of which use machine learning technology perfected from years at Amazon. And some of these services we kind of looked at in our session on Monday. And today's session is focused more on SageMaker. So SageMaker puts machine learning into the hands of all developers and data scientists, allowing them to quickly build and train and deploy their machine learning models at scale without a lot of effort. For advanced practitioner, we also have unmatched in the flexibility we give them with the support for all the popular open source framework optimized for training performance. And 90% of the data scientists do use multiple frameworks, and that's because algorithms are being invented, all the time by different people in different frameworks. So Amazon strictly, or AWS strongly believes in making sure that we support all the major open source frameworks. So in that sense, we support TensorFlow, PyTorch, MXNet, and others. And you will see that irrespective of which frameworks or which models you use, you'll find a place in SageMaker. You'll find an equivalent functionality where you can bring and keep using those open source frameworks. Secondly, we can also accelerate your adoption of machine learning. Again, like I said, SageMaker, before SageMaker, doing machine learning was kind of hard for our customers. And by making ML easier at low cost, customers can now make better use of their data, which is both valuable and differentiated. Models that previously took customers months and extensive specialized expertise can now be built in weeks or even days. And AWS has also invested in acceleration programs, including an ML Solutions Lab and education and training programs for Deep Racer and Embark to help organizations more readily adopt machine learning. Finally, you can also be confident when you make a choice with AWS platform that you're working with the most comprehensive cloud platform optimized for machine learning. That's why today, if you look at the amount of TensorFlow that runs in the cloud, more than 85% of that TensorFlow runs on AWS. And we also have a team that basically is focused and dedicated to optimizing TensorFlow performance, for example, in AWS. So we spend and invest a significant amount of time and resources to ensure that we are unbiased in our approach and we offer the broadest and the most capable platform for our customers. Finally, you also want to make sure that whatever platform you're using offers you a highly secure and a reliable and full-featured data store with the right access controls and security. So from that perspective, also the maturity of AWS Cloud in general and the fact that we've been doing it for more than a decade now is kind of it's a boost, and it helps our customers decide and make their choice in terms of the preferred platform. This approach, quite frankly, it resonates with our customers, and as such, you can see that more ML happens on AWS than anywhere else, from the largest enterprises through to the hottest startups. AWS has over twice the number of machine learning-based public references than any other provider. So companies are working with us to build solutions that are core to their business. On the technology side, ML should increasingly be integrated into just about every aspect of your business. And then from that point, to do so, you require a new stack that is tailored to the unique needs of the business entities. So some of you who were present here for our session on Monday might have seen this diagram. And basically, we look at the machine learning space into 3 layers. The one at the bottom is kind of what I described quickly, where we talked about the fact that we support major open source frameworks, along with a wide choice of compute systems, or what we call as EC2 instances. So we have various EC2 instance families that you can use, and you can optimize different kinds of infrastructure needs for that reason. And then in the middle, you have SageMaker, which is what we are focused on today. And as you will see, SageMaker is an end-to-end platform, and we can use it all the way from data labeling and all the way to hosting and automating the hosting of these models once they're trained, and being able to create these endpoints, as we call them, to be able to make predictions in real time as well as in batch. So throughout the discussion today, we'll look at what some of those stages are, what some of those capabilities are. Like I said, at the bottom layer, it's the frameworks layer and the interfaces layer. And we kind of spoke about it. We support the major ones here, as well as we provide the broadest and deepest portfolio of infrastructure services around it, right? So for example, our Amazon EC2 P4D instances, which are new, they provide the highest performance for ML training in the cloud with the latest NVIDIA A100 Tensor Core GPUs, coupled with the first in the cloud 400 gigabits per second instance networking. So these are highly capable machines, and they're deployed in something what we call as EC2 Ultra clusters, and that's how they are able to provide the almost the HPC level of performance for our customers' most demanding workloads. Coming back to the middle layer for SageMaker, as you can see, there's not many expert ML practitioners that are available. So if you want ML to be pervasive, you have to make it easier for everyday developers and data scientists to build and train the models, right? So in that respect, this middle stack is exactly geared towards that. As you can see, there's various functionalities all the way from pre-processing your data or looking at your data, visualizing it, to creating code for your models, and then be able to train them irrespective of the data volumes that go into training by making use of distributed training, for example. You have the ability to train quickly and then finally deploy the outcome of these training jobs in the form of models as endpoints. So basically, this is, again, in terms of functionality, you will see that with SageMaker, what we built is from the ground up, we built it for every developer and every data scientist with the ability to create and complete all these steps, right? Whether that is building them, training them, or deploying them, and in a very cost-effective manner. So the tools that you will see, for example, you will see that there's a lot built in to the platform already, and the data scientists or the developers do not have to rely on many external factors or external systems to pre-process that data. Amazon SageMaker is also the most complete end-to-end service for machine learning. It is managed service for data scientists and ML operations teams that helps remove the undifferentiated heavy lifting associated with any machine learning workload, so that you, in turn, can have more time, resources, and energy to focus on your business. SageMaker has a lot of features and a full workbench of capabilities. So we'll go through the 4 pillars that typically go into any kind of machine learning workload. So first off, SageMaker provides users with an integrated workbench of tools brought together in one place through SageMaker Studio. Users can launch Jupyter notebooks and Jupyter lab environments instantly through SageMaker Studio. SageMaker also provides complete experiment management and data preparation and pipeline automation and orchestration to help make data scientists more productive. If you've used Jupyter notebooks, for example, you will know that they need a computing environment to run on. So SageMaker provides fully managed servers and in the cloud to make this easy for the data scientists and developers. But even beyond the notebooks, SageMaker provides other managed infrastructure capabilities as well, from distributed training jobs to data pre-processing jobs, even model hosting. SageMaker takes care of all of the scaling, the patching, the high availability, etc., that is associated with building, training, and hosting any models. So there are tools within SageMaker that help make data scientists more productive. What you'll see is that this is the integrated workbench sitting on managed infrastructure is also enriched by a huge ecosystem of tools, all purpose-built for machine learning and designed from the ground up to work together. Again, in terms of the 4 pillars that we kind of talked about, typical machine learning cycle includes the data preparation. So in support of that, we have our components within SageMaker. There's a component called ground truth, for example. There are capabilities like Data Wrangler that have been announced this year, like basically December 2020. And these capabilities give you a single pane through which you can pre-process your data from within SageMaker Studio. And you also have the capability to do any processing right there, along with any feature store. So feature store is new as well. This was also announced very recently. The idea here is that as your data scientists perform various cleaning or feature extraction activities, right, on your raw data. And once they create this data, instead of just using it for that specific model, you can create this feature store where you can centrally store the definition of these features and then have the ability to use a consistent definition for those features throughout various models. So if you're familiar with any kind of model development, you'll see that that is typically an exercise where different data science teams have to redo potentially similar activities in terms of data prep, and they end up spending kind of a redundant amount of time there. So this is definitely geared towards solving that problem. Now, in terms of build capabilities, again, um, as you will see that we have the studio notebooks themselves where you're writing, they provide you the interface for Jupyter notebooks that I talked about, and they give you the capability without you having to install any Jupyter environments. They are ready to go environments, and you have the ability to then marry them to any type of compute or memory needs that you might have based on the workload you're working on. And you have the ability to create code that you can then use for training and hosting later. Now, one of the key concepts to remember is when you're working with these Jupyter notebooks, you don't need to rely on the capacity of the notebook itself to be able to train. So in other words, if you have large amounts of data that you need to train with, you can actually, using a small instance on which you're running Jupyter to write your kind of building code for the model, you can trigger these SageMaker jobs that spin up additional infrastructure, and they automatically, everything is containerized. So they automatically spin up additional instances behind the scenes, and the training is fully externalized from these Jupyter notebooks. And you just kind of point those instances to a central data location, which is typically an S3 bucket in the AWS ecosystem. So you point to your data, you through the API, you initiate this training job that spins up the required amount of infrastructure, completes the training, takes out the outcome of the training, which is a trained model, puts it back into a persisted storage layer, again in S3, and then it shuts down every resource, right? So from that perspective, you as a developer or a data scientist don't have to manage the underlying infrastructure. And you don't have to always keep running these large instances because you're doing training with large amounts of data. You can have a really small Jupyter Notebook instance running, which is basically just a trigger to these massive jobs as your needs may be. And the second these jobs finish, you stop paying for any resources that you might be utilizing. So that kind of goes into the build aspect or the second column in the slide. And then the training and tuning I described to some extent. There is one-click training. In other words, you just point it to data. You don't have to worry about any infrastructure. You can specify how much, or if you want 5 small servers to train in parallel, or you want 1 large server to train for 5 hours. So you can pick and choose those choices from there. And there are also features when you're doing your training, once your model is trained, for further tuning using hyperparameters. There are capabilities within the SageMaker platform where you can provide these hyperparameter ranges, and various kind of tuning jobs are performed on the trained model to find the most optimized combination of hyperparameters, and thus further tuning your trained model. So all that is built in through the Bayesian algorithms, and behind the scenes, they are utilized to identify the best performing model. And they also have the capability, instead of letting the model training run for, let's say, 500 iterations, if you achieve your validation objectives sooner, they have the ability to shut down the job sooner, and hence saving you money there as well. There are also capabilities for debugger and spot training. So spot, if you are not familiar with AWS, might be new terminology for you. But the idea behind spot training is that when we have additional capacity in any of our environments, we generally are able to offer that at a significant amount of discount to our customers. So in other words, let's say if you're paying, for example, this is just a made up example. Let's say you're paying, 20 cents an hour for a certain size of an instance. If that same instance was available through Spot, there are chances that you might be paying only 4 cents or 5 cents for the hour for that same instance because we have additional capacity. So one of the core concepts built into SageMaker is because these are typically distributed clustered jobs. If your model or your training job has the ability to wait a little bit, in other words, it does not need to start immediately, you within your code, you can specify that you want to leverage these spot instances. And when you do that, if the job is able to leverage them, in other words, if additional capacity is available in time, let's say, and your job can wait 15 minutes or 5 minutes, and those instances can be made available, chances are you can get away with paying only 80 or 90%, sorry, only 10 or 20% of the cost of an on-demand instance. So from that perspective, there are huge amount of savings that are potentially possible. And this is built in to the platform to be able to leverage those concepts from the get-go. In terms of deployment and management, so one of the key things that you will see, and we always talk about even in reInvent, for those who are familiar with our annual session or the conference, we always focus on the training as well as the kind of the inference, right, or the prediction or deployment or hosting separately, right? Because one of the things that is key is you might be spending a lot of resources in training, and as such, a lot of customers focus too much on just optimizing for training. But the chances are, once you have trained your model, you are going to run it, a lot longer. So your training job may be heavy, but the job may finish in, let's say, 2 or 5 hours. Whereas the model that you've trained and now you're going to use for, let's say, day-to-day predictions, that model will most likely run 24/7. So it is important not just to optimize during the training time, but equally important to optimize when you're deploying these resources. So we typically categorize that as inference. So during inference, when you're deploying these trained models, we provide unique capabilities for our customers to be able to deploy these models in a fashion which saves them money. So a few examples or features that help enable that are things like, for example, you can there are custom developed chips that we offer, which give you great price performance for running these kind of endpoints, right, forever. Similarly, you also have the option of utilizing a partial GPU. So in other words, if your model inference benefits or is accelerated by making use of GPU, GPUs are typically quite expensive, and having a full GPU attached to your inference instance could mean additional cost, right? So if your workload or your model benefits from having a GPU, but you don't quite need a full GPU, let's say, Amazon offers you options to have a partial GPU that you can on demand attach with these instances. So basically, it's a way to attach the right amount of GPU capacity to these inferences, right? And then saving money because you're not paying for the full GPU. Again, I'm just kind of like, this is an extensive platform. There's lots of features because we have been building these based on the customer feedback for years now. And it's kind of hard to describe every single one of them, but I'm trying to highlight some of the most common considerations that our customers have, and that can help you determine the fit and also give you the comfort that you have a lot of controls in terms of controlling the cost of your workloads. Now, again, in the spirit of saving money, you also have the options to deploy multi-model endpoints, as we call them, wherein basically through the same instance, you can deploy more than one model. And then depending on the URL or the endpoint being invoked, you can route it to the appropriate model behind the scenes, right? On the other end of the spectrum, if you need to go, let's say your demand increases significantly, and you need multiple instances during inference as well that need to ensure that your workload is, the performance is not degrading for your customers. We provide automated scaling on these inference endpoints where, an endpoint is kind of logically behind a DNS entry, right? And then it points to more than one instance, and automatically the traffic is managed based on the load between these instances. Again, on deployment, it's kind of hard to include every feature, but one of the other key one that I can think of right away is the ability to do to deploy multiple versions of the model. So for example, if you're doing A/B testing, let's say you have a model that you are happy with, and then you train a new version of the model, which you believe should be more effective, but you're not sure of it. So in that scenario, for example, through the deployment through to the endpoints, you can do what we call as model variants. What that gives you is the ability to route, let's say, 80% or 90% of the traffic to your existing model, and then deploy the new one and route only a partial amount of traffic to the new one. So as you see the predictions come out of the new model, and if you are satisfied with the performance of the new model, you can then gradually shift your kind of load from 10% to the new one to 100% or however much you want to make. So in other words, the platform not only gives you the ability to kind of just train the models, deploy them, it is a fully thought out platform which gives you the ability to be able to make these changes in production, right? And be able to either scale, cost optimize, secure, or be able to provide you the most flexible platforms in that sense, right? Again, like I said, while being able to do things quickly or being agile is great, but to build and train models rapidly, it doesn't do anything for you, right? If you can't get your models to production reliably or repeatedly, so and securely, right? So from that perspective, you often want to look at not just the machine learning capabilities of a cloud provider, but also the overall maturity in terms of the security offerings, in terms of compliance offerings, in terms of the controls that a particular provider can provide over your data. So the good news is that there's a balance between ML agility and IT governance, and the SageMaker platform fully integrates with all of the other AWS services, whether that is for logging purposes in a centralized place, or for audit purposes, or for being able to encrypt your data at rest as well as in transit. So the common services that enable the AWS platform for even non-machine learning workloads are also integrated fully well into the machine learning services. And you can have a consistent experience if you're a AWS user. If you're already used to, for example, working on your logs in a central location because you make use of services like CloudWatch, or you make use of CloudTrail for your audit needs, the SageMaker services or other AI services, they integrate fully well with CloudWatch and CloudTrail. And you have the same ability to have full visibility into who's doing what kind of models are being deployed, what kind of training jobs are being run, and who is initiating, who's consuming how much. Also, in terms of SageMaker provides you robust IT ops features across security, workflows, scalability, and orchestration. So like I covered a few things in terms of security, in terms of compliance also, you can achieve PCI or HIPAA compliance depending on whatever type of workloads you're running. The SageMaker service is DevOps ready. Basically, we publish the kind of the cloud provider side of the reports, and our customers are typically able to build on these reports, then achieve compliance for their own needs relatively quickly, because parts of the compliance requirements that are infrastructure and are a responsibility or typically fell in the purview of the data center teams in the past are taken care of by the cloud teams now. This is just one of the customer kind of case studies where Thomson Reuters they have been on a journey to migrate their data centers, and they were looking to migrate 7 of their data centers into the AWS cloud. AWS cloud is their preferred cloud provider in terms of their choice. And while they were doing it, they were looking at SageMaker as well for their ML needs. And one of the things that they originally saw, because they had multiple teams that were working in silos, they were having significant kind of redundant time spent and significant technical issues that different teams were trying to solve. So once they started utilizing SageMaker platform, and they also came up with this concept of secure content workspaces within their enterprise. And what they did is they integrated the two, and they created a central platform where they integrated it with SageMaker. And now there any of the data scientists or developers that need access to various kind of data objects, they were able to centrally govern and provide full visibility for all their users. And they were able to rely on SageMaker for all of the usual building, training, and endpoint hosting needs. And as a result, they were able to solve for the challenges that they were facing originally, and were able to migrate their data centers successfully. Now, in terms of kind of like architecture, they, like I mentioned on Monday as well, typical implementation for any AWS solutions will involve typically more than one AWS service. So in this case also, as you can see, they were using SageMaker for training and hosting, as well as they were using for the central storage, they were using S3 buckets, along with the GitHub repositories for all of their code that was in the Jupyter notebooks, right? So cohesively, they kind of created this solution in different roles within the organization, where they had the content owners who provided guided access to the data scientists, and they created a kind of a request platform where scientists were able to look at the available data sets and were able to request them from the content owners. And then through the workflow orchestration, the content owners were then able to provide the right access to the data scientists. And then once the data scientists got access to the corresponding resources, they were able to spin up the appropriate SageMaker resources and create various models. Gartner has also released its 2020 solution scorecard for Amazon SageMaker with an overall score of 84 out of 100. And this is the highest kind of rating amongst any of our peer groups, right? And according to Gartner, we meet the 87% of their required criteria and 73% of the preferred criteria, along with 85% of the optional criteria that they put together. So they also recognize us as a leader in the first Magic Quadrant for cloud AI based on ability to execute as well as completeness of vision. So one of the things that you will see they rate various organizations on is, from left to right, how many features have you envisioned, right? How many features you have enabled, as well as how many features you have envisioned. So not only we have the highest ability to execute because of our maturity in the platform, but we are also the most forward-looking kind of organization in terms of what needs to come in for the future. All right, so with that, I did keep a lot more time for today for demonstration. So we'll jump into the console, and where I'll showcase what SageMaker looks like. And I will also show you, maybe walk you through one of the typical notebooks and show you how a model can be used end to end. And then hopefully towards the end, we'll have some time for questions and answers. Screens, I'm bringing a browser into view. Please let me know once you see that on the screen so that I can continue with the demonstration. Okay, hopefully everybody can see it. If not, please interrupt me. So let's get started from just SageMaker in general. So one of the things that, if you haven't seen AWS console before, as you log in, you will see a few things here. So this is one of my accounts, so you can see who is logged in. You can also see we have a concept of regions. So region is basically the control for various customers as to where their data is located and where these services are running from. So we have a region in Canada, and for today's demonstration, that's what I've picked. So we have a region in Canada, it's called the CS Central 1. That's where everything I showcase you today is going to be running from. But you have a choice for running your workloads from any of these regions. So we have multiple regions in US, both in the East and the West, and multiple regions in Asia, as well as in Europe, right? So chances are wherever your customers are and your workloads need to be, we have presence and we can help you, equally easily to spin up resources in various geographies. And you can still be compliant also in terms of, if you need to contain your data within a certain geography, in other words, not let the data flow into the US or Asia, you can keep everything contained within Canada itself. So that's the idea of regions. It is important to select the appropriate region. Sometimes you'll see the customers will, they forget which regions they deploy their resources in, and later on they have trouble finding, oh, why can't I see the instance I had spun up? Because they might be in a different region from where they originally started. So do pay attention to where you are when you're utilizing that. All right. So with that, this is, again, once you do that, you can actually, so this will be your default view. So this is the AWS Management Console. And from here, you can see there is multiple kind of links, not only to the services, but also to various solutions, right? So if you're very new to AWS and you, for example, don't know how to spin up a new virtual instance, and these kind of quick guides can take you through a guided way to actually run those resources. So they help you with various use cases from here. Similarly, there are full-on solutions as well. So you can go from here to various videos and tutorials or blog resources as well. And again, for almost every service or area, including machine learning, there are blogs that are categorized. So if you search for AWS machine learning blogs, you will find a dedicated blog, which will have various publications coming in on the topic. So if you subscribe to these blogs, you can keep following what's kind of new happening in the space all the time. Going back to SageMaker, so you can, if it doesn't show you into the recent services, it shows for me because I use it quite often. But if it doesn't show, you can start with a search here. So you can basically select your service from here. And once you click on that, this is your default view. And as I was explaining, this is kind of a dashboard view, and it shows you all of the different features that are available within the platform, all the way from data labeling. So ground truth is a component service where you can, for example, if you're trying to do supervised learning and you don't have a lot of labeled data available, you can designate teams within your organization and have them, like, this is kind of a workflow orchestration. So you can assign various team members to various resources that they need to label, and they can manually start labeling those resources. And behind the scenes, this component has also features to start auto labeling. So as it sees the human labelers kind of create those labels, it tries to use machine learning behind the scenes to create those labels for you without human intervention. And it gives every label a confidence score. As you process more and more human label data through the service, you will start seeing eventually a point where the automated labeling will surpass the human capability. So the idea here is that eventually you can create this component service where, instead of relying on human beings to label data, you can label in an automated fashion for further model training. And obviously the cost of labeling instead of through humans, labeling it through an algorithm is going to be substantially cheaper. So the idea here is, as you iterate through large amount of data that you need to label, for example, you can eventually achieve a lot of cost optimization and automation for even the labeling jobs, right? So once your data is labeled for supervised learning, this is the part where I was talking about notebook instances. This is, kind of the development environment where you have Jupyter installed, pre-installed. All the frameworks are pre-installed. You don't have to worry about, configuring any GPUs depending on the type of instance you choose. If the instance has a GPU attached, the GPU will also be available to you for utilization, right? Similarly, the SageMaker within it has the training jobs, the inference job. We talked through this quite a bit when we were talking on the slides. So I'll skip. But the idea here is that it gives you kind of an overview of the typical steps needed in any machine learning workload. It also shows you kind of what is running. So for example, right now I have an endpoint that is in service. In other words, I have one endpoint that I've deployed very recently because I wanted to showcase that. What an endpoint is, it's an API based, it's a always running server basically, right? And it has a specific model deployed, and I can make a request to this model through an API call. So I can embed basically the predictions from this model into any kind of web interface or any kind of mobile interface, because all I need to do is call an API endpoint and get the response back. On the left, as you can see, there's quite a bit of sort of navigation. All the things that you see here in the middle as to how to do them, they are also neatly labeled through the links on the left, right? So for example, ground truth. If we look at ground truth, you have, if you click on ground truth, you'll see how the labeling jobs typically work, how you specify different data sets, and how you create different workflows. So in other words, you could start creating new jobs. You'll give it a name, you'll give the location of the input data. You will also set up the data manually or in an automated fashion. You will also choose the appropriate security control. So one of the key things that you'll see this everywhere throughout the session, any resources or any functionality we're triggering will also require an IAM role. So an IAM role is, IAM stands for Identity and Access Management. And what this means is for anything you're trying to do, the user that is logged in and is accessing these resources needs to have the right permissions. So for example, when I talked about your data may be stored in S3 and you're triggering a model that needs to have access to that data in order to run its training, well, your instance that you're going to fire needs to have the appropriate permissions to that S3 bucket. So in other words, just because the data is located centrally does not mean it's free for all. The data is well guarded, and you can create within the organizations, you can create different roles, and these roles can be assigned to different stakeholders based on the level of access that they should have to the data. So in other words, this is the mechanism that connects it to the security and gives you the ability to control who should be able to do what. This is just giving you a few examples of, like, for example, what kind of labeling is being done. Are you labeling for the type of sport in the picture? Are you labeling for the different objects in a picture, for example? Are you drawing bounding boxes? Or in other words, within the picture, are you trying to identify a certain species of birds and finding their coordinates? So again, different types of data labeling jobs that can be performed here. The scope of this service in itself is quite extensive, and like I said, with any other service, if you want to learn more, you can easily spend a day just getting to know these services. But the idea of this session being introductory in nature is at least to make you aware of all the components or functionalities that are available in the platform. So that's about ground truth. Similarly for notebooks, if I show you the notebook instances, what this means is I have the ability to spin up these Jupyter notebook instances ready to go. I can give it a kind of a name, right? And I can choose how large this instance should be. So for those of you who might not be familiar with what these things mean, right? I can quickly, so AWS EC2 instance families. So you want to make sure that you kind of become familiar with what the terminology is, right? So if you look at instance types, as you can see in this link, for example, oh, by the way, we have recently introduced Mac instances also now. So in other words, you could have you can spin up a virtual Mac machine in the cloud that you can utilize if you are working with that, which is a recent addition. That's why I bring it up. But as you can see, there's different families of these instances. And what that really means is there is different amount of compute and different amount of RAM that is available through different instance families. So depending on the size, you will be allocated a certain amount of CPU and memory. And whatever your needs are, According to that, you can find the corresponding sort of instance type that you should utilize. Now, on EC2, there is a much broader list of instance types, and a subset of these instance types is available here. So basically, that's what it means. If I say, a T2 extra large versus a T2 2x large, that means 2x large is typically double the capacity of an extra large. So both the CPU as well as memory are typically double of what you have in extra large. So that's just one of the other things to know is these are also categorized by various type of optimization. So if your workloads are compute heavy, for example, you can choose one of the compute optimized instances. What that means is for a required amount of money that you spend, right, you will get more CPU than the RAM. So if your workload is compute intensive, you don't have to pay, just because you need more CPU, you don't have to spin up an instance that also has a lot more RAM, right? So if you go with the compute optimized instance, you'll get more CPU for the same amount of RAM, and you'll be paying less because you're not paying for additional RAM. Similarly, if your workload is memory intensive, then you typically start with R type of instances. So the idea here is that depending on whatever type of workload you have, you can choose the kind of the appropriate amount of resources that you want to spin up. Like I said, for majority of the times when you're running with Jupyter Notebook instances, you can get away with running typically a large or an extra large instance, and you don't have to go really large, because if your needs go beyond that, you can always spin up additional training on hosting instances outside of this instance, right? So you don't have to run this. Think of this as a development instance, right? This instance, chances are, if you're working 8 hours a day, you're going to be running it throughout the day because you're coding on it actively. And you don't want to run a really large CPU or memory instance, because if you're just creating code and running through small iterations, then you can get away with a much smaller instance. And if your code truly does require bigger ones, then you can spin them through the commands in the APIs, right? So you typically start with a small one there. And again, you have these options are kind of beyond the scope of today's discussion, but from a security perspective, you can run these instances into what we call as VPCs, right? They are virtual private clouds. What that means is at the networking layer, you can keep these instances fully private. In other words, these instances are not going to be accessible from the internet at all, and they will be fully contained within that private cloud or private network that you set up within AWS. And only through the private setup, they will have access to the data resources. In other words, these will not be internet facing. So again, these are some of the controls at the security level that various customers are able to exercise. Now, if you're not inclined, if you're just experimenting and you don't want to spend a lot of time configuring all the networking behind the scenes, you can leave it as such. That's why it's optional. And then resources run in the default VPC in your account, and you don't have to worry about all of these things. Similar things, again, optional, but if there is a Git repository with which you want to interface, so all the code that you write in your Jupyter notebooks, you want to make sure that you're able to save that, and you're able to utilize that later in other instances, so you can integrate it with Git as well. Again, the idea here is I'm just showcasing you how easy it is to get an environment that you can start coding immediately, instead of, now I configure an image and then I have to update the corresponding Linux libraries. Then I have to go back and install the CUDA drivers. Then I have to, download the open source frameworks, and hopefully the drivers I have, they work with the frameworks, right? So all of that, when you spin up this instance, is already done for you. When the instance comes up, within a matter of minutes, you have a ready-to-go environment at your fingertips. Again, similarly, just wanted to showcase what the interface looks like. Similar area, you can see various algorithms that are available for training jobs. You can see all of the training jobs that, for example, I have run in the past. You can see them here. You can see the history of each of those training jobs. You can see exactly, how long it took for the training job to finish, how much, in other words, for this job, I paid for 56 seconds of the training time, what kind of data resources were utilized during the training and things like that. Again, this is all from a central visibility console. And all of this is, by the way, also logged into CloudWatch, where you can see that in a central place as well. Okay, after the training, similarly for endpoints, remember I said I pre-deployed an endpoint to showcase during the demonstration today. So that is this endpoint. I'm using an XGBoost model for one of the really common use cases. And I'll show you once I go to a notebook what I'm doing there. But you can see that this is deployed on an M5 extra large instance. And all of my traffic is right now going to this instance because that's the only instance I've deployed. But I could have easily deployed it behind an endpoint that utilized multiple instances, for example. And if my needs were such that I needed to have large amount of traffic being handled, right? It also shows you the model that I've trained and I've deployed on this instance, right? And the corresponding training job that created that model. Okay, so coming back a little bit. Oh, by the way, when we are talking about inference, not only you have the ability to create these endpoints, which you can call in a real-time fashion, but there's also a concept of batch transformation jobs, right? So in other words, if I don't want to have an instance running 24/7, and let's say I have 100,000 records that I need to predict on every night, I can create these batch jobs where basically kind of like the training, an instance is spun up, the model is deployed, and then all of your input data is processed and predictions are generated on your input data, and they are persisted back into centralized storage. And then this instance goes out of existence. So in other words, if you have batch workloads where you need to make predictions only 2 hours a day, at night you can fully automate it, and you can make use of these batch transformation jobs to be able to make predictions in a batch fashion. Right, so that said, let me also quickly go into SageMaker Studio. So this is actually one of the really exciting ways to utilize or access SageMaker. All of the things that you saw here, they are pretty easy to use from the GUI right here. But what SageMaker Studio does is it's an integrated development environment. It gives you access to, through a centralized pane, it gives you access to be able to do almost everything that you do here right from within the studio. And it makes it easier for you, in other words, to experiment with different things. So with that, I have an instance of Studio that I've already configured. And I just before our presentation, I kind of came here and I integrated or I copied the GitHub library. So one of the things to know, if you're just getting started and you're not sure how to use SageMaker, for example, there is an open Git repo. So if I look for AWS GitHub SageMaker samples, you will find SageMaker examples. So you'll find a repo here, which is basically, it covers most of the features that are supported by SageMaker. And it has ready-to-go code within these folders that gives you kind of a sample of how to make use of that specific feature. So if you're getting started and you don't know exactly how to do it, this is your friend. You can copy this Git into one of those Studio instances, just like I did. So basically, to do that, all I need to do is, by the way, when I say launcher here, you will see I have all these options to launch various things. And one of the things there is my ability to launch what we call image terminals, right? So this is basically just like getting an SSH prompt, right? If you were running a Linux instance yourself and you wanted to install something additionally, this is the equivalent of that. So once I get this, for example, I get the launcher. I then have the ability, I can actually get the system one instead of the image one also. And then I have the ability to run various type of commands, just like the Linux command. So one of the things I did was I did a git clone on this instance to be able to copy all of the SageMaker examples from that GitHub repo into this central place. So once I do that, then I get the ability to, so for example, in this notebook that I copied, I get the ability to execute this notebook because I have copied the content into my local instance. I can execute pretty much any notebook right on this instance here. So, and as you can see, right, if you look at it, there is various examples, various features that are shown. The one that I kind of always advise to get started is the SageMaker algorithm example. So let me just pull up where I have this image from. I think it's a, let's see, not under here. Sorry, this is a multi-level path. I sometimes get confused as to which folder I'm referring to, but there's lots of resources here that can be really useful if you're just getting started. So frameworks, get started, introduction. I think it's introduction. Yeah, okay. So as you can see, this folder contains various notebooks that provide you introduction to different Amazon algorithms that are available within SageMaker out of the box, right? Even if you have, by the way, an algorithm that's not available within SageMaker, you always have the ability to bring your own algorithms as well. So for the purposes of what is already available, you'll see that these span different areas. So there is linear learners, there is k-nearest neighbors, there is the XGBoost, there is blazing text for your NLP needs, and object-to-vec, which is for mostly for computer vision, I believe. So like I said, again, there's multiple algorithms that are available. The one that we are taking a look at today is called XGBoost Abalone. What this is basically, this is a kind of a shell that is found in the ocean, and the data set for the input for the features, in other words, are the physical characteristics of the shell. So basically various dimensions of the shell across different diameters and stuff. So those go as input, and the outcome of this model's prediction is the ability to predict the age of the shell. So this is using an open source data set, I believe, which is being downloaded from this location. So I'm pretty sure if we wanted to, for example, take a quick look at what this is, this might even provide us with like some instructions on what those features are, right? So for example, in here, okay, yeah, this is the data set itself. I'm pretty sure we can find some documentation as well. And if you need, I can help you locate the documentation later. But the idea here is that, like we were looking at that URL, it's basically a collection of various characteristics, right? And then the final outcome is the age of the shell that is being predicted. So this first column is the age of the shell. That is basically the label for the supervised learning. And all of the rest of the columns are describing the input features. I think it's in the libsvm format. Yeah, libsvm format. So it basically says the first column, the value is that, and the second column, the value is that. And the kind of the placement of these columns has a special meaning into the model as to what that feature is. Now, how do we go about utilizing that data set and creating a model that predicts the age looking at the example data, right? So in this case, this notebook, all of this code, by the way, when you copy from the GitHub examples, you have access to all of this code in a central place, and you can immediately start making use of this code. So in here, for example, we are splitting the data into training, validation, and test data sets, and we are uploading it back into S3. So S3 is, if you remember, I said this is a centralized storage where everything shows up. So in this case, under SageMaker, for example, I have the XGBoost model. So in here, these three kind of folders or subfolders are created through my code in the notebook. And this is where I have basically various objects that are loaded, right? So this is where my data set is. And all of this is happening because I'm creating a training and a validation and a test data set in that location. And I'm doing all of this through code. So upload to S3 is a method that is written here. And all it is doing is it is creating those objects into S3. So basically download from the URL, split the data into various training, test, and validation, and push it into S3 so that the model, when we're running the training, the model can make use of that data. So from the beginning of the notebook, once the data set is ready, you can see if you are not familiar with Boto3, Boto3 is the Python SDK for working with the AWS library. So in this case, for example, all of the SageMaker API that we are invoking using Python code. And you can also see that, by the way, from the choice of the kernel that I have here. My kernel is a Python 3 environment, along with some data science libraries that are known to it, right? So if you're running in SageMaker, you don't have to worry about installing any AWS dependencies. All of the environment dependencies are pretty much there. All you do is you start with importing them into your notebook, and off you go. You can start writing Python code to interact with SageMaker. So in this case, for example, you're setting up the kind of the location of the data set from central buckets. You're setting up the location of the output, which is basically your trained model. When your training job finishes, it is at this location that the model will be stored, right? One of the key things to understand is all of these steps in SageMaker are decoupled. What that means is if you chose to only train your model within SageMaker, but deploy it elsewhere outside of SageMaker, you can do only the training. In other words, the model that is persisted back into S3, you can take that model and deploy it elsewhere into any of your on-prem resources, for example. Or if you have a pre-trained model that you've already trained elsewhere, and let's say you want to host it for making real-time predictions using SageMaker, you can also bring that model into SageMaker and just use the hosting side of SageMaker. So in other words, you're not constrained. You don't have to use the platform end-to-end. If you have existing resources that you want to bring in, or if you want to use this platform only to create models and then maybe deploy them elsewhere, you can do all of that. So in this case, okay, first we set up all the different paths and locations, right? And then we kick off the training job. So training job in this case, because XGBoost is one of our known models, right? So algorithms. So it's already known. So you don't have to bring any installables. What we are doing is we're just specifying that we are going to be using XGBoost for our training and our hosting jobs today. And we are able to specify a specific version. So the documentation in AWS states what versions are available. And the beauty is you can choose various versions for your needs, right? So this is all it takes. You specify a specific location of the container. So like I mentioned, everything behind the scenes in SageMaker is containerized. So you're basically pointing it to a ready-to-go container image. And then you're pointing through this create training parameters kind of object. You're specifying the different locations. So you're specifying where the outcome, which is the trained model, where that should be stored. Similarly, you're specifying all the hyperparameters that should be used during the training. You're also specifying the number of instances that should participate in the training, and the size of each instance. So you have direct control as to how large or how much you're paying for this training, because you're specifying how large an instance you're running during the training. So once you do all of that, there's some settings that you do. Finally, when you do the create training job, that's when it pushes that job. And you remember when we looked at the kind of the GUI here, and under training, I was showcasing training jobs. This is the job that I finished. It took about 3 minutes. And this is the job I finished today before the demonstration. So this is a job that we kicked off from this code, basically. And then once the job is kicked off, because depending on the size of the data, it can take some time, we are then polling that job to see if it is finished in status. So it's either completed or failed for some reason. And then we poll it. And then we can see that it completed within a matter of 3 minutes. And then once I have the job completed, the outcome of this, by the way, was stored in my S3 location again. So under this folder, you will see that for each iteration of the job I did, under the output, I got a model.tar.gz file, which is basically my trained model based on that data set now. So from that point onwards, I'm now setting up the hosting. So I'm just specifying the model location from the job, I'm taking the model and I'm creating what I call the endpoint configuration. Again, kind of similar. You give it a name, you give it how large an instance you want to run the hosting on, how many instances you want, and all of my traffic is going to this one instance. You remember I told you could have done multiple instances. Excuse me. So this is where you could have defined more than one type of production variant. And you could have said 80% of my traffic goes to this, 25 or 20% of my traffic goes to another type of instance. So this is the configuration through which you control that hosting environment. And once you do that, you finally create the endpoint itself. You give the endpoint a name based on a timestamp. You create the endpoint, and then again, once we create the endpoint, again through the GUI, you can see if you come back here in endpoints, that endpoint gets deployed basically in the SageMaker environment. And once that endpoint is deployed, now you have a ready-to-go environment. You can start making your predictions. So again, in this case, you can pretty much see I'm creating a runtime environment for SageMaker, and I am reading from my test data on S3. I'm reading a specific line so that I can make a prediction. So I'm reading one of the lines from the data set from my test environment, and I take the data, I specify, I send it to that specific endpoint. So I'm invoking that endpoint here, and I get a predicted outcome from that, which I'm printing here, right? So label is my original age from the data set, and prediction is what came out of the model. So as you can see, the original age as known to us from the data set was 12 years, and the predicted was 13. So pretty close, but not exactly right? So again, with machine learning, you'll always see certain type of variance. This is also, the code is also showing you how to do a batch prediction. So this is doing the prediction in a batch format on a larger data set. And then we do run the median absolute percentage error, which you can see comes to be about 0.14, right? So again, this is a small data set. If you have a large amount of data, if you run through a lot of optimization, you can get much more accurate results. But the idea here is to, instead of focusing on the accuracy, the idea here is to showcase to you, pretty much within this notebook, right? All the way from downloading a data set to pushing it into the central location, to running a training job, to creating a hosted endpoint, to making predictions both in real time and in batch. This code kind of gives you all of that in one place, right? And then once I'm finished, which I haven't executed right now, all I need to do is I need to select this. And I need to, once I execute this, that endpoint that I'm paying for, that will go away. So if I, for example, if I was just playing with it and I don't need it to keep running, I can clean up the environment and not have to keep paying for the resources. So hopefully this is helpful. Again, I know this is a lot of information packed. And with that, I'll kind of stop here, take a pause, because I really want to also take a few questions towards the end. And hopefully the session has been useful for you today.